Find the root of f of x. In this problem, we are provided a third-degree polynomial f of x, as well as 4 possible roots. Although there are quicker ways to solve this problem, we'll use the secant method. The secant method starts with two initial points, xn minus 1 and xn minus 2, as well as the function itself, f of x. We notice the possible answers range between 4 and 10. Therefore, we'll choose two initial values outside the range where xn minus 1 is closer to the range than xn minus 2. Keep in mind we're dealing with a third-degree polynomial, which means it could have only one real root. Or, the root we're solving for may be the smallest root, or the middle root. Back to the secant method, we'll assign variable xn minus 2 to be 15, and variable xn minus 1 to be 12, because the 4 possible roots are 4, 6, 8, and 10. To make the notation simpler, we'll call 15 x1 and we'll call 12 x2. Therefore, the next point will be x3, where n equals 3. After plugging in 3 for n and plugging in x1 and x2, all we have left to solve for is f of x1 and f of x2. We'll solve for f of x1 by plugging in 15 for x1, and f of x1 equals 7,425. To solve for f of x2, we'll plug in 12 into our equation, and f of x2 equals 4,224. Now we can solve for our value of x3, which equals 8.04. If we plot out point x1 f of x1 and point x2 f of x2, then our equation to find the next value of x simply draws a straight line between these 2 points, and our next value of x is where that line intersects the x-axis. Next, we'll check to see if 8.04 is a root for f of x. After plugging in 8.04 for x3, we compute f of x3 equals 1,461, which means 8.04 is not a root of the function. Therefore, we'll solve for x4 by plugging in the values of x2, x3, f of x2, and f of x3, which makes x4 equal to 5.95. To determine if 5.95 is a root, we'll plug in 5.95 for x4, and f of x4 equals 558. Therefore, 5.95 is not a root. If we rescale the x and f of x axes and solve for x5, we get x5 equals 4.66, which makes f of x5 equal to 161. If we show our 5 points in a table, we notice the value of the function is approaching 0. After 2 more iterations, we notice the algorithm converges on 4 as a root to the polynomial. When reviewing the possible solutions, the answer is A.